Good afternoon, all the teachers. So today we are going to discuss about the next topic related to the machine learning, that is machine learning classification. So let me share my screen with you. Can you give me the quick confirmation, Kathy? Is my screen is visible?
Yes, your screen is visible.
Yeah, thank you. So today we are going to discuss about the next problem statement, which is called as a classification problem statement. So before starting the session, I just want to give my small introduction. My name is Raje and I'm a instructor for today's session. So about me, I have an experience of 20 years. I taught to the different college faculty members as well as the students on the different technologies like AI, ML, as well as the one API. Then we can say mobile application development and website development. So this is a small introduction about me. So let us start for the today's session. So maybe in previous today you have discussed about the machine learning and what is deep learning, right? And what are the different types of the machine learning? You already know about now supervised machine learning and unsupervised machine learning, right? And again for this supervised machine learning, yesterday you already learned about the regression type of problem statement. Today we are going to discuss about the next type of problem statement, which is called as a classification. And there is another machine learning type, we can say, that is a unsupervised machine learning. So there we are going to learn about something called as an dimensionality reduction. Okay, principal component analysis. Yeah, you can say you are going to learn about something called as an clustering, right? So this is not the agenda of today's session, but for your understanding, you may learn about this in upcoming session. So today we are going to focus on this classification part, right? So first understand what this classification is. So classification problem statement, whenever you will get some problem statement, then you have to understand what that problem statement is, whether it is supervised or unsupervised. If you observe that the problem statement is a supervised problem statement, then again you have to check whether it is type of regressor or it is type of the classification. Now how we can understand this is a classification type of problem statement? For that, you have to just check the target variable. So if your target variable is of the categorical variable, okay, it means it is something called as an classifying some unknown items into some distinct set of classes, then you can say it is a classification type of problem statement. Okay, now take this example. So this is one example where you are going to predict the loan defaulter. So bank want to check that how many loan defaulters are there. So in this case, this part which I have shown you now at the right hand side, this is nothing but an your target, right? So you have to check for the target which type of variable it is. Now, for example, this is your target variable default, and it is having some values 1 or 0, 1 or 0, right? So it is having the two categories only, either 1 or 0. So then if this is the case, then we can say it is a binary classification problem statement, because there are only two possibilities. That's why we can say it is a binary type of classification. Okay. Then moving ahead, if we have the categorical variable, Now again, we are going to check our target variable only. We are not going to check our this input variables, okay, input features. So we are just focusing on our target variable. Now in this case, this is another problem statement. You have to identify the drug classification, drug prediction you have to do on the basis of the inputs. Now in this case, this drug is our target variable, and which is of the categorical type. Now here the categories are drug Y, drug C, you are going to observe here. Next category you are going to observe here as a drug X. So these are repeated one, right? Drug C, X, and Y. So here we can say there are more than two categories are available in the target. So we can say it is a multi-class classification. So just remember, whenever any problem statement is there, you have to check only for this target variable. If it is a categorical variable, then you can say it is of the classification type. Now there are only two categories, then we can say binary classification. And if it is more than two categories here, like it is shown here in this case, then it is called as an multi-class classification. I hope it is clear to everyone. Can you give me the quick confirmation in the chat? Yes. Okay, fine. So this is just basic. This is already known to you. So moving ahead, so these are a few examples that you may face. Yeah, you already gone through this, right? For example, predicting the category of the customer in which he is belong to. Yeah, famous problem statement in our data science is the churn prediction. Then you can go for the another type of problem statement, like advertising campaign, right? So to whom we are going to focus more, to which customer you are going to reach out. Another type of classification applications are nothing but an email filtering, right? So whether that email is spam or not. Something next one is something called as speech recognition, then hand recognition, right? So the biometrics identification, document classification, and number of things are there, right? So you have to identify just what type of problem it is, and for that you are going to use some classification algorithms. Now, next thing is that whenever you are getting whenever you are going to face any problem, right? So as a machine learning engineer, yeah, you can say as a data scientist, you will get some problem, right? So you have to understand that problem first. After understanding this problem, you are going to try to provide some solution to that problem, right? So how you are going to provide the solution? There are some steps that you have to follow. First step is that you have to identify it. So which category it is. So now, for example, as I told you that you are going to identify with the help of supervised machine learning or unsupervised machine learning, right? Then you are going to find out with the help of whether it is classification or regression, if it is under the type of the supervised machine learning. So this is the first step that you have to perform, right? So next step is that you have to, whatever the data you have, so this data is nothing but your raw data. Okay. So all the data is raw data. So raw data means you may have some blank values, you may have some duplicate records, right? So that data may not be at a particular scale. So you have to perform that feature engineering and feature selection task. Okay. So this is your first, third step that you have to perform: feature engineering and feature selection. So in the feature engineering, what you are going to do? You are going to perform some basic operation that is nothing but your cleaning of the data, then finding out the duplicate if it is there. Okay, and then you are going to go for this next step, which is called as feature selection. For example, in your machine learning problem statement, there are 100 features are there. Now here the features means columns, right? So whatever the most important columns are there, most important features are there, that you are going to be identified. So once it is done, then you have to find out which algorithm, which classifier you are going to be used, right? Classifier, regressor you are going to be used. So generally in this, it is called as an estimators. In our machine learning language, it is called as an estimators. Now you have to find out which estimator you supposed to be used. Okay. Now for this, converting this raw data into the useful data, I can see you have some libraries which is called as an pandas. You already learn about this pandas, right? Then something called as an numpy. And for to plot something, you have some library, one library which is called as an matplotlib. Generally, we are using this. Along with this, we are going to use the Seaborn also, right? So we'll use the Seaborn also. So this is for the visualization. But for this, converting raw data into the what you can say useful data, you are going to use, generally you are going to use these two libraries, pandas and the numpys. Okay, along with this, you require the third library, which is called as an scikit-learn, right? So to perform the scaling operations, normalization operation, you are going to use the scikit-learn library also. Okay. Now, you don't have to write any type of algorithm. The algorithm is already available. Estimators are already available. You have to select the appropriate estimator. Now, who is going to provide you this estimator? This estimator is going to be provided by this scikit-learn library itself. If you go to the scikit-learn official website of the scikit-learn, so you will find out there different types of estimators are available, right? So apart from this estimators, today we are going to learn about the this classification estimators. So there are a number of estimators. First, we can say it is a decision tree, then naive Bayes, linear discriminant analysis, k-nearest neighbor, logistic regression, okay, support vector machines, as well as the neural networks. So today we'll try to finish this decision tree. So definitely you will get something value added from this session. Okay, so we'll keep the theory very less, and we'll try to do the practicals more. Okay, so that it will be the hands-on for you. Next, after identifying this estimator, you have to create the model, right? Now, what is the use of model here? So model is used for the predicting the data. Okay, something you are going to be asked to that model, and it will give you some prediction. And that is the role of your machine learning engineer to create this model, right? Once this model is created, this is your fifth step, we can see. Once this model is created, next step is that you have to evaluate your model. You have to check the performance of your model, right? So for this classification type of problem statement, there is different evaluation methods are there, right? So that also we can discuss. What are the different types of evaluation methods are there, and which evaluation method is best at which condition, that we will discuss later on. Okay. So generally these steps we have to follow for creating the model and defining the model. So in last 2 days, you already learn about this 3 steps. Today we are going to learn about this 4th and 5th step for this classification algorithm. Okay. So let us go for the next part. So before going to the evaluation matrix, so we'll go for this one. Decision tree. We'll understand the concept of this, and then we'll see that after creating the model, then we'll discuss about the evaluation matrix, which are available for the classification. Now, decision tree is a one type of classifier. So we'll start with the discussing on it. Okay. From the participant, can you give me any confirmation that this decision tree slide is visible to you?
Visible, sir.
Okay, thank you. Now, for this particular decision tree, we'll start our discussion with the agenda that what is this decision tree is. Okay, and then we'll discuss about the different terminologies which are available, which are going to be used in the decision tree. Okay, then we'll discuss about the different splitting methodologies. So we're going to split this decision tree. So what are the different splitting methods are available? Yeah, you can say algorithms are available. Okay. So that you can discuss. We will going to discuss now, because see, to design a model with the decision tree classifier, it is just a 5-line of code task, right? But we have to understand this part, which method is going to be used. And next, we'll discuss about the criteria about this. What are the different criteria in which, at what area we can say, and what condition we are going to use which method. Okay. Then we'll see at the end, we'll see the implementation part of this decision tree with the help of our Python code. Okay. So we'll use the Jupyter Lab and we'll write the code for it. Okay. And at the end, we are going to discuss about the something called as an to draw the decision tree. How you can draw the decision tree. That we'll discuss. So moving ahead, what this decision tree will be? So something, the structure something like this is nothing but an tree structure. Now here you are observing some nodes, right? And then some branches are there. Okay, yeah, you can say it is some splits are there. And at the end, you are having some values, that is yes and no. So we have to draw this type of decision tree. Okay. Now for the problem statement, problem statement that we are going to get. So that problem statement will be something like this, right? So we're having something Excel file. Yeah, you can call it as an CSV file. Yeah, data will be in any format, right? So we're going to convert it into some data frames by using the pandas. Now assume that we have this type of data. And in this data, all these are the input features, and this is our target. Now, as I told you, this is the target we can see, and all these are nothing but our features for this particular problem statement. And this is called as your, up to this we can see, this is called as your sample. Okay. Now, can anyone unmute and tell me how you are going to, in last session also, you already learned about the regression type of machine learning problem statement, right? Now consider this is a machine regressor type of problem statement, and tell me what are the steps that you're supposed to be followed for designing the model, creating the model. Anyone from the participant can unmute and explain this. So what I just want the explanation about how you are going to create the model, how you are going to develop the model. Okay, can you tell me what is the label here in this case? Can you tell me the label?
Yeah, for present ID, age, sex, and BP, drug regarding
Sorry, sir, but your voice was not properly audible to me, at least.
patient ID, age, sex, BP, and cholesterol.
So these are what labels?
Labels, sir. Labels.
These are the labels. Any other participant? So question is, from this diagram, can you tell me what is the label here in this case?
Drug, sir. Drug.
Drug. Okay. Drug, yeah, drug A. Yeah, this drug you can see. You're able to, you're trying to convey me that drug is a label, right?
Drug.
Yes, sir. Yes, sir.
Drug is a label, and in this there are categories: drug A, drug B.
Correct. Correct. So try to understand this concept first. So it may be a value addition to you. So this is our column, right? Drug is a column name, and drug is having some values, right? So we'll forget about, now in this case, we'll forget about what this drug contains. Yeah, drug, what is the value of this drug column is. Now here we can see whatever this column name is there, that is nothing but our target. Okay, that is nothing but our target. The question is asked related to the label, what the label is. For example, I told you this is a sample size, right? From this to this, that is P1 to P14 is our sample. Now consider this sample number 6. Okay. Now this total is called as an observation. Single thing is called as an observation. Okay. And in this case, P6 row, for this row, it is nothing but an label. Okay. This value is nothing but an label. Got the point? Now, at the last, we have asked the one question for this observation, for this input features, give me the prediction, yeah, give me the label, right? So you already learn about the definition of this, what you can say, supervised machine learning. So in the supervised machine learning,
Drug B.
we are going to be provide something called as a label
Yes.
along with our input feature, correct? Okay. Now this label is nothing but an this part,
Drug B.
correct?
Drug B.
Yeah, we'll see the answer later on, but try to understand the concept. Okay.
Okay.
So I hope I am able to convey the message that I want to convey. So in this case, all these labels, in this case now drug A is a label. So we are going to pass these labels also at the time of training, okay? And at the time of what you can say, predicting something, we are going to pass only this input features, and then my model is going to provide me the label as output. What the concept? Hello? If you got the concept, please type yes.
Yes, sir.
Yes, sir.
Sir,
Yes, yes, please.
are you getting, sir? Voice is coming?
Yes, sir, yes, you are audible.
Yes. So, sir, how we build a model, sir, actually mathematical, how to write a mathematical model for it? Suppose, suppose Y parameter is
so here in this case, we can say y equal to f of x.
f of x, right, sir?
Right,
So
right.
these are the variables like A, sex, BP, and cholesterol.
Correct.
The x parameters, right, sir?
Right, right.
And drug is the y parameter. So how we build a mathematical model? So what will be the, how to calculate the coefficient of these variables?
Now here in this case, coefficients and all that things are not there. This is the case of the, this is another type of problem statement. Yesterday, whatever you have discussed, that is in that case, coefficients and that things are there. It is for the regression type of problem statement. Okay. So moving ahead to this topic. So once we can give the label as well as the input features to our model, then we can say we are going to build a model. Now for this building the model, we are going to use something called as an decision tree. Now in the decision tree, these are the what you can say features, right? So we have to start with some feature. For example, this age is a one feature, sex is a one feature, BP is a one feature, cholesterol is another feature. So we have to start with one feature. For example, here in this case, age is taken as a root node to draw the diagram, right? To start the decision tree. And till that, we're getting some nodes, which is called as a leaf node. Now here, if you observe, there are two drugs, which is shown here, drug A and drug B. The circle, which is called as an red color, it is a drug A, and triangle, we can say it is a drug B. Now, if you will get this type of pure nodes, then we have to stop. Pure node means the nodes which are having the homogeneous values. Okay. Now, in this case, all the values of the same category at this side and all the values at the same category at the another side. Then it is called as an pure node. So the main objective of the decision tree is that to find out the pure node. Okay. Next. we may select the another category, for example, cholesterol. But the problem is that which one is best? Yeah, which one will give us the best pure nodes, we can say. Yeah, we can say which will give you the correct decision tree. Okay. So there are some techniques to understand this. So first we'll discuss about the technique which is called as an, yeah, you can see before that we can understand this. Whatever this is nothing but an this portion is called as an your root node. Okay. And this is called as an split. This is called as a split. Right. Now in this case, high and the normal is the criteria for the splitting. Now in this previous example, each we are going to be split here. This is the split. Now in this case, we have split this each with the young, middle, and the senior. Okay. Now if you observe here, we have some criteria for the splitting. We have to decide which, yeah, how you are going to create this type of splits. Okay. So for that, there are different techniques we can see that we'll discuss. Now, before going to that splitting techniques, so first understand another terminologies that are going to be used. So we already discussed this pure node, right? Pure nodes are nothing but an your leaf nodes and the nodes with the homogeneous values. Okay. And this node is called as an your root node. Okay. The root node contains the entire population. Yeah, you can say this is the first node that is to be split. The next node we are observing here in this case is called as an your decision node. Okay. Now try to understand this, because whenever we are going to create the model, at that time we are going to change these values, yeah, change these parameters, and then we are going to optimize the performance of our model. Okay. Then this part is called as an subtree. So this is a subtree. This is also the subtree. Now, next important thing is that depth of the tree. Depth of tree. Now, in this case, the longest path from root node to the leaf node is called as an your depth of the tree. Now, in this case, if you observe here, depth is 2. Okay. So moving with this basic terminologies, that is pure node, then root node, then you can say depth of the tree. Okay. We'll go to the next point, which is nothing but an different techniques that we are going to be used. So you may heard something called
Sir,
as
can you please repeat, sir, depth of tree, how to calculate depth of tree?
Okay. So longest path of that tree from root node to the leaf node, that is called as an your depth of tree. For example, in this diagram, if you start from this, so it will reach to this leaf node. So I can say this is only the depth of 1. Okay. Now in this previous example, so I want to calculate the depth of this tree. So I will start from this. This is my first one and this is my second one. So I can say depth of tree is 2. In few cases, you may get the higher depth of 1. So now can you tell me the depth of this tree? So those who have asked the question, can you tell me if it is clear to you, can you tell me the depth of this tree?
2, sir.
Correct. Correct. Now, why we are learning this? This is also the important point. Why I'm investing some time to understand this, right? Because when the data set is large, now if you observe here, this type of data set you're getting. Now, for example, in this case, we have only 15 observations, right? So this is a very small data set. So at that time, it's okay, our model can perform, our model can create the decision tree till the last end of the, without, you can say, without providing the number of leaf node criteria. So he will go to the in-depth for creating the decision tree. But consider that you are solving the problem which is having the lack of transactions, right? So that number of sample size is very large. So at that time, if you will consider, you will keep the depth very large. So it will take more time to compute, right? Computation time is required more. At that time, it requires the what you can say, more time to calculate each and everything, right? So, and if the your another criteria is that if this number of features are also large, right? In this case, I have only this 4 to 5 features, but the features are more. At that time also, it will take the more time. So we have to think all these points at the time of providing some input to our data, input to our model, we can say. Okay. So that's why we are learning this. So we'll see one example at that time. We'll get this knowledge in detail. So I purposefully kept these slides blank. So now we are going to discuss about something called as an methods for how we are going to split, right? So in this case, what is the split? For example, this cholesterol is there, right? This is a feature name. And this line is nothing but an split, high and normal. Okay. So we have to check which criteria, which features is going to be selected. For that, we are going to learn the different methods. So can you tell me any one method that you know? Yeah, that you already use for the decision tree classifier. Already you have used it. Okay. Can you go to the website of the scikit-learn? All of you are requested to go for the website of the scikit-learn. And try to find out the decision tree classifier. Okay, go to the documentation of this. and tell me the answer of my question. Which method is used here? By default, which method is used for splitting? Anyone from your side? I'm not asking about the train test. I'm asking about the decision tree classifier. Split method, which is by default method in the decision tree classifier. I want this session to be more hands-on. Can you go for this? Okay, go for this link. Try to open it. Now tell me, is it open? Now tell me which splitting criteria is used here by default. You can type it in the chat box. Do it fast because we have to implement the correct Genie. Thank you, ma'am. Correct answer. So you are able to see here something called as an criteria, right? So default criteria is Genie here. Okay. Please observe this. Whenever you will going to implement any type of estimator from this sklearn, yeah, you can say scikit-learn library, try to go for the documentation of this first, okay, and then you can implement it. Now here you are going to observe here something called as an criteria. This is the first parameter which is mentioned here, and by default parameter is Genie. Now next question is, what is Genie? So you are having this parameter which is called as an Genie. I gave you the demo also, right? So we are going to discuss this methods now. Okay. What is Genie? Anyone? Okay. So Genie is
Yes, sir.
yes, ma'am. Please go ahead.
I think Gini is a function that determines how well we split our decision tree.
Correct. Yeah, I'm typing here something in the chat box. Genie is sum of square of all probabilities. Probabilities for each class. Okay. if you say the in my particular data set, I have only two probabilities, probability 1 and probability 2, right? So I can say Genie equal to P1 square plus P2 square. Okay. Now, to calculate the Genie, yeah, you can say after finding out the Genie for each node, you have to add it for the all the classes. Yeah, you can say all the nodes of the decision tree. For example, my decision tree is something like this. Okay, and this is called as an something called as an grade 9 and grade 10. Okay, and I have something called as an A, B, and C. This is my node names. Now, as to calculate the Genie for this, I have to calculate the Genie for this. Okay, and if I will calculate, then I have to add this both the Genies for this subtree. Okay, similarly, as to calculate the Genie for this one, and then again I have to add it, and then I will use the one method which is called as an Genie impurity. The method, first method name is Genie impurity. So in the Genie impurity, so our main task is that to find out the Genie values. Okay, so I already told you what is Genie is. Now, how you are going to calculate the Genie impurity? Genie impurity is nothing but an 1 minus Genie. Now consider you got some value of Genie, okay? And that value is to be subtracted from the 1. So remember, lower the Genie impurity is the best for us, okay? So we can say this value should be the lower one. Genie impurity value should be the very low. Okay, if it is low, then we can say we'll get some homogeneous node. Homogeneous node means maximum nodes of the same category at the different side and maximum nodes at the same category for the another side also.
Hello.
Okay. Yes, sir.
Jimmy.
Hello. Next method is that, so you already aware that next method which is called as an calculating the information gain, right? So in the information gain, you are going to calculate something called as an entropy. I'm just listing out all these methods. So when we are going to calculate the entropy, after now entropy is having some formula that is you already know about that, minus P 1 into log of log of 2 P1 minus P2 log of 2 P2 up to Pn log of Pn, right? So if you calculate that entropy, so you are going to find out the entropy values, right? So whatever that entropy is there, that entropy should be the lesser one and the information gain should be the higher one. So how you are going to calculate the information gain? What is entropy? Okay. Entropy is nothing but there is one formula to calculate the entropy. The formula is P1 log base log 2 to the P1 minus P2 log of 2 to the P2. Now these P1 and P2 are nothing but, and for example, the classes, yeah, you can say number of classes in my particular problem statement. Okay. Suppose I am having the value played cricket or not played cricket. So these are the two classes in this case. Yes, suppose I am having the value of drug A, drug B, and drug C. So in that case, three classes are there. So I can add another one, that is a P3 for the drug C. So I will calculate that values. So this is nothing but an probabilities values up to n number of probabilities of the classes that you are going to be checked, and then this value will give you the entropy value. Okay, so whatever this entropy value is there, that entropy value you have to minus it with from the 1. Then you can say it is an information gain. Okay, now this information gain value should be the higher one. So in this case, in the first example, Genie impurity is we are considering this, it should be the lower one, but this information gain value should be the higher one. So we are going to select the node which is having the higher information gain. Okay. Now, this is the thing that I have discussed with you. For example, here there are two classes, drug B and the drug A. Now we have the 9 occurrence of the drug B and the 5 occurrence of the drug A. If you put this value in this particular formula, you will get the entropy of for that particular node as a, for example, 0.398. So we can round it as a 0.94. And for the information gain, so we'll minus this value. So this is nothing but our information gain. Okay. Now, similarly, we have to calculate the this entropy for all the nodes. Now, here, if you observe, we have the samples, 9 samples for B and 5 samples for A. So we got the entropy with this formula as a 0.94. Similarly, for this next node, we have to calculate the entropy. Now, for the entropy for this is, for entropy, we require the observations. Yeah, you can say samples. Now here, 6 are the B category and 2 are of the A categories, drug A categories. So if you put this now value 6 and 2 into this particular formula, then you will get the value as a 0.81. Okay. Now what we observe, we say that information gain should be the high and entropy value should be the less. Entropy should be the minimum one. Okay. So similarly, we have to calculate this for different feature also. Now for this feature, so this is for the cholesterol. If you observe here, we have calculated this for the cholesterol. Now we are going to take the another feature here. For example, this sex feature is taken. Now for this sex feature, how many are there? For example, 9B and 5A. So 9B examples are there and 5B drugs examples are there. So again, with the help of that entropy formula, we are going to calculate the entropy for this node. Again, we are going to calculate the entropy for this node, number of females and the number of males. For this case, number of samples, when we can say female is there, then drug B equal to 3 and drug A equal to 4. Okay. And then we got this value after entering this E values, we got this value as a 0.985. Okay. And what is the weighted sum of this means? You have to add this. Now this is the value of the weighted sum of this. Okay. Now, similarly, now here, for example, we have calculated the information gain for the two features, sex and the cholesterol. Now, the value of the information gain, which is having higher one, that we are going to select for the decision node. Okay. For example, we say that cholesterol is having the higher information gain than this sex feature. Then we are going to select this cholesterol for the next split. Okay, we are going to find out which feature is going to be selected for the splitting one. Okay, that we are going to be identified. So with the help of these methods, we are going to identify this one. And remember, this is work. All these two methods will work only for the categorical data. If your data is the categorical, then only it will work. Remember this. So another technique is there for selecting this is nothing but an reduction in variance. So we have observed this two methods. One is your information gain, okay, and second one is your Genie impurity. So next, third one is also available, which is called as an reduction in variance. So I will write this as a third. So please note down this because I know that few of you are not aware of this reduction in variance. Okay. Now this method is going to be used when your data is of the regression type. When your data is of the regression type. Okay, this is the difference. And whatever the previous two methods that we have discussed, that will work only on the categorical data. When your target variable is the categorical one, then only the previous will work. Okay. And if you have a problem statement related to the regression, your target variable is of the regression type, then you want to use this decision tree. At that time, this methodology is going to be used. Okay. So moving to the next part. I'm going to share one link with you. So it is requested that you can download this data sets. Once it is downloaded, please let me know, then we'll go for the implementation part. So this is a data set. So from this data set, we're going to use this data_clean.csv. Okay, if it is done, then open the Jupyter notebook. So let me open my Jupyter notebook. So you can also open the Jupyter notebook along with me. Now I'm sharing my screen with you. Okay, I hope you have opened the Jupyter notebook. So please import this required libraries. After that, open this file data set. Read this data set in Pandas library. Now we have this data. Try to find out how many number of rows are there and how many number of columns are there. Now here we observe that there are 891 rows and 25 columns. Now if you go for this data.head, this is our target, right? Supervise 0 or 1. Okay, so this is a Titanic data set. So we're going to check how many are survive and how many are not survived. Okay, by using the decision tree algorithm, and then we'll discuss how to improve the things in the decision tree. Okay, next, this is a very important step that you have to find out whether it is having any null value or not. Done. After that, if you observe here, we don't have any null values. So all here it is mentioned as a 0, 0, 0. Okay. Then we are going to separate it now, whatever the values we have. So we want this first column as our y value, that is our nothing but an target variable. Okay. And rest of things we are going to be kept in the x value. That is nothing but an input feature. So now in this case, our X is the input features and Y is our output feature. Okay. Now we are going to split our data. So for that, we are going to use this sklearn.model selection train test split. And next, we are going to use train test split function. Okay. And in this train test split function, we are going to use this 35. So why we are going to use this 35? Because it will homogeneously distribute. Yeah, you can say it will distribute my training data set and testing data set. Yeah, you can say validation data set into the equal distribution of samples. So that I'm going to use this 35. I want the equal distribution. Okay. Now, if you observe here, now try to run this code, right? So after running this code, you will observe the meaning of the 35. So generally we are not using this, but it is better that you can use this because whatever the samples you have, for example, you have 10,000 samples. So randomly it is going to take the samples. If you are going to use this train test split, so it will take it randomly. So you don't know how much samples he has taken, right? Algorithm has taken for the training and how much samples are taken for the testing, right? But to make the equal distribution for the training as well as the testing, we are going to use this parameter to yes, that is 35. Next thing is that we'll see the now how much percentage wise number of data is available with us. It means we have two classes. If here we have observed that there are 0 and 1, right? So in the zeros and 1, how many zeros are there and how many ones are there, that you will observe. Now with the help of this y_train.values count function, you will get the count of that. But with the help of the normalize equal to true, we are getting the output in the form of percentage. Now I can say number of zeros here in my data set are 61.67% and number of ones are 38.32%. Now here, if I observe the percentage, it is the imbalanced data set. So that data set is not balanced one, I can say. Okay. Next, if you see the data now, this is for your training data and this is for your testing data. So whatever this testing data is there, that also you can check. Now, if you observe this, both the values, number of zeros for the training and number of ones for the training, it is equally distributed, and that is happened due to this stratify equal to 1. Okay. So this is a benefit by using the stratify equal to yes. Then with the help of this next command train dot shape and ytrain dot shape, you can easily find out the number of rows and columns for the training and the testing. Now this part is very important for us. Now we are going to, now it is not the case that decision tree is only used for the classification problem statement. It can be used for the regression type of problem statement. Yesterday you have discussed about the regression type, right? So if you are using the regression, if you are solving the case of the regression, and then you are going to use this regression, if you want to use this decision tree algorithm, at that time you can use this regressor, which is called as a decision tree regressor. But for this example, we don't require this one. Okay. So for this case, we are going to use this decision tree classifier. So remember, decision tree is going to be used for solving both the type of problems. Next. So we are going to call this, we are going to instantiate this decision tree with some random state. Where keep this random state equal to, for example, 10. Why we are using this random state? Because whenever we'll run it again, so it will give you the same output. Otherwise, the output will be changed. Next, to train our model, you know that we have one method which is called as a fit. So to train the model, we are going to provide this two parameters, X train and Y train. Now try to go for the next one. Check your training performance. Check the training performance with the help of this model.score, X train and Y train. Now, if you observe here, we got the training performance that is 0.9880. It means at the time of training, we learn a lot of things. Our model will perform well. But when we give this testing, if you are going to check the testing part of validation part of our model, then if you observe here, the value is very less. You can say smaller than this training score. Okay. Now, which type of problem it is? Whether it is whether it is underfitting or anything else. So we got the good training performance, but we got the lesser testing performance. You can say validation performance.
Underfitting.
No, it is overfitting.
But sir, when the output is less and the input is more.
No, see, when we can say it is a overfitting, that whenever our model is performing well at the time of training, and whenever model is not performing well at the time of testing, okay, then it is called as an overfitted. Overfitted means मुझे आपने जब ट्रेनिंग दिया तब मैं बहुत अच्छी तरह से आंसर दे रहा, बट एक्चुअली व्हेन यू आर गोइंग टू आस्क सम क्वेश्चंस टू मी, so at that time मेरा performance low हो गया.
Exactly. Right. But if you see, sir, the value it's 9 point. Okay, it's 0.9. Yeah, got it. I was thinking 7.5. Yeah, definitely. Now the value is lesser. 7.5 is lesser than okay.
Right.
9 point is lesser than 7.5. Got it, sir.
Yes. And if it is a reverse case,
then that would be overfitted.
Correct. At that time, whatever you are saying, it is a correct one.
Yeah. Okay? I didn't check the value. It was decimal. Yeah. It's fine, okay, sir. Thank you, sir.
Now, our target should be to find out the generalized model. Okay. So we are going to find out the generalized model. So what do you mean by generalized model? So my training score should be in a particular range, and testing score should be at the same range. Okay. So that should be my objective for designing the model. If I will say this is a problem of overfitting. Okay. My model is not performing well. Okay. Then I will check with the help of some model.predict. Probability I am going to be checked. Now, if you observe here, number of zeros and number of ones, probabilities of number of zeros and number of one. So this is my first column. That is a value of the zeros column. Okay, and this is my this second one is nothing but my values column which I got for the second class. That is a one class. Okay, if you observe here, when we use the probability values, so it will take the threshold value as a 0.5. Okay, if you go through this, it will give you the value as a 0, 1 or 0.5. Okay, so by default, this function predict underscore probability gives you the threshold value as a 0.5. Now you can check the performance of your model. Yeah, you can say you can tune the performance of your model. Okay, by changing this parameter. Now, for example, I want the second column only. So I will take this second one. And now what I'm doing, I'm going to change this parameter to 0.7 instead of 0.5. So this is a small line of code. If it is less than 0.7, then it will goes to the 0. If it is greater than 0.7, then it will goes to this next value, next column. Okay. And I'm interested in the one values only. Now, if you observe here, again, if you check the our accuracy score after running this, it may change. Okay, it may increase or decrease. Now here, for example, this is 0.733. Now previously what you got, so that is nothing but an 0.7533 only. So it is not changed now. Okay, even though your change is to the 0.7. So you have to find out with the another parameters also, whether it is changing for the 0.6 or 0.8. So accordingly, you can do that. Another parameter is that you can take the you can change the performance of your model with the help of changing the value for the maximum depth. If you can recall that from your previous, yeah, you can say just 30 minutes before we have understood the concept called as an depth of the graph. Okay, so we can, with the help of this max underscore depth of your decision tree, you can change the, yeah, you can say tune your performance of the model. Okay, now for example, this code is written here, just finding out the which depth is going to give me the best result. Okay, so here I'm going to check the training score as well as the testing score. Now for that, maximum depth we have taken from the 1 to 10. Okay, so it means we are going to check the value of the decision tree if depth equal to 1, depth equal to 2, depth equal to 3, something like that, up to the depth equal to 10. Then we got something called as on this, and same we are going to be plot with the help of some graph. So if you observe here, this is my training score. Okay, my model, how my model is performing. Okay, now if you observe here, this another color line is shown here, which is called as my validation score. Now at the when the value is equal to 1, it means that depth decision tree depth equal to 1. So at that time, my performance of the training as a testing is the same. Okay, yeah, it is starting from this 0.8 something. Okay, and if you observe here, when the depth of the tree is increasing, 1, 2, 3, 4, 5, yeah, you can say after this 6, it get increasing, right? And if I observe here, when my decision tree depth equal to 8, it is increasing here. And but for the validation test, after 8, it get decreased. My performance, it get decreased. So what I can observe here, if I will keep this parameter, that is the depth of the tree equal to 8, then I will get the good performance. Okay. So this will check with the help of this particular graph. Now we are redesigning our model. Okay, so with this parameter. Now what is the why in the redesigning, what we have done, we have calculated this maximum depth. Okay, so maximum depth is 8, and after 8 it is decreasing, so we are not going to take this 9th one. So maximum depth we have taken as a 8, right? And maximum leaf nodes we are kept as a 25. So we can change this value leaf node and we'll check the performance later on. Okay, so don't keep this value very high and don't keep this value very low also. Okay, then if you run this with the help of model.fit, because we are now retuning our model, we are going to train our model with this new parameters now. Okay, now if you observe here, if you check the model score now, it gives you the 0.8802 now. And if you check the validation score, check this validation score with the X valid and Y valid. Now it gives you the 8116. Now I can see my validation score is also good. This is my validation score, and my training score is also good. Okay. So this type of performance we want, right? So this is called as an you are tuning our model with the help of finding out the different, changing the different parameters. If you observe here, so with the help of shift tab, you will find out the another parameters also. Like default parameter is Genie. Okay. Now, what are the another parameters are available? For example, if you go for the documentation of this, another is called as an entropy. So we have discussed about the entropy, right? So you can change this value. For example, suppose I ask you to change this value instead of Genie. What you can do now? You can change it to the entropy. Change this to the entropy now. And tell me, did you getting some difference here? Okay. So in this way, we have to check how you are getting the good performance of our model. Okay. Similarly, you can go for this part also. How many samples you want for the splitting? Minimum samples for the splitting. So by default, it is 2. It means whenever the next split will happen, it will check at least minimum 2 samples are available. You can increase this value and check the performance. Okay. So this is important that you should go for each parameter, and then you can observe here the change of the performance. Okay. Next, you have to import some library which is called as a tree. We are going to draw this decision tree. So whatever you got here, so that is going to be drawn. So make sure these libraries are installed on your Jupyter notebook. And then you will get this type of graph for the decision tree. Okay, it will show you how many samples are there, which method is going to be used. Okay, what is the value of that method? Everything is going to be mentioned in the decision tree graph. Okay, now next thing I want to show you here, which is related to the random forest. So difference between decision tree and random forest is that in the decision tree, it will generate a one decision tree only. Okay, and it will generate the sample data randomly for the training. But in the decision tree, what you can say, random forest decision tree, so it will generate the number of decision trees more than one. Okay, and then whatever the average value is there, so that average will be taken and it will be provided to you. That is only the difference here. So this is another data set. The same things are applied here. Now, if you observe here, we have done the same steps that whatever we have done for the previous one. Now, if you want to use the random forest, you have to use this random forest classifier. Now here we have provided the estimator equal to 100. Okay, it means it will generate the 100 decision trees for your problem statement, and whatever the average values are, best one is there, that will be provided to you. With the help of this, definitely the performance is going to be increased. So this is about the random forest. So that's it from my side. Today we'll stop here. And I have the another data sets.
Hello.
Just a minute, sir. I have the another data sets for you, which I will give provided to you. Don't stop for this only related to the decision tree. So I will provide you the data related to the k nearest neighbor also. Some files I have prepared for you, but due to the time restriction, it is not possible to conduct each and everything here. Okay. Now you can go for the k nearest also, as well as you can go for the support vector machine also. Okay. So these are the another two classifiers we are going to be used for the classification problem statements. Okay. So I will share each and everything with you related to this, and try to focus that go to the sklearn libraries, and whatever the parameters are there, you can use that parameters for increasing the performance of your model. Yes, sir. Hello. Yes, I will share my number with you. My number is 9923723839. My email
Sir,
ID. Yes.
sir, yesterday I asked one question to the presenter. Sir, the question is, sir, when you download some files, some data files, data sets from UCI repository, it is having extension .tar.gz. So how to convert the .tar.gz file into CSV file?
Okay. Now that .tar.gz files are generally given for the, what you can say, Linux users. Okay.
Yes,
So
sir.
with the help of tar commands, you can convert it into the proper format. Okay. So
Sir,
you can
you in Windows, is there any procedure?
in Windows, we can check it for with the help of WinRAR if it is available. Otherwise, you can use the tar one. So I will provide you that link with you. Can you share
Okay,
your
sir.
number? Yeah, you can WhatsApp me on this thing.
Sir,
I will
what is,
share this with you.
sir,
Okay.
sir, what is your WhatsApp number?
9923723839.
99
23839.
23839. Okay.
Okay.
Sir, once again,
37
99
238 39.
238.
39, sir.
Okay, sir. 99
Yes, sir. Yes. I have
Okay, sir.
posted it on the chat, in the chat also.
Okay, sir. Okay, sir.
And email IDs, everything is small. yogesh@edunetfoundation.org. This is the email ID. So I will share the link with you. So try to do the practice on that, and try to do the practice on the more data sets. More data sets means the data set which is having the large number of samples. Okay. Thank you. If you have any queries, please, the session is open for you now. If it is not, then we're good to stop now. Kathy, are you there?
Sir, are you there? Are you going to share these sets, these examples?
Yeah, I will share each and everything with you.
Okay, thank you, sir. So can we leave if we are done?
If it you already mark your attendance, then
Yes,
it's
yes, sir. Yes, I have marked.
yeah,
Okay.
because few participants are asking.
Sir, attendance link is
Actually, I don't have that attendance link. I'm just presenter, so I'm not having any idea about that. So definitely it will share.
Teachers, I'll just update the attendance link in the chat box. Meanwhile, if you have any queries, please let the trainer know. I request all of you to be attentive for the attendance link because it will be active for 4:15 only, till 4:15. So those who are yet to mark their attendance, please mark your attendance. I have shared the link in the session, sorry, in the chat box.
So, Kathy, can I share this data with them?
Yes, Yogesh, I have added you in the WhatsApp group. You can share the documents or files over there itself.
Okay. Here also I have shared the link.
Yeah.
You can go for it.
I have added you in the WhatsApp group itself. The group name is FDP, DS and ML using Python. You can access the group and share the details over there.
Yes. I received that group name. I will share there also. Thank you, teachers, for listening to today's session. Thank you so much.
Thank you, sir, for your kind efforts.